Hello and welcome back to another episode of Math with Sohn. Today we are going to be doing AP Physics 1 and we're going to be learning about friction, which is something you've probably heard about in the past, but we're going to be dealing with friction as a force. Okay, so if you're pushing an object along, like we have this box here, if we're pushing it to the right, the force of friction is going to be counteracting that and pushing it backwards to the left. And there are two different types of friction. There's something called static friction, which is when an object does not move, and there's something called kinetic friction when the object decides to move even though there is friction opposing it. So static friction occurs whenever you're trying to push an object that is just plain old too dang heavy, or when the friction is just so great, like if you were trying to push something that was like stuck together with glue, okay? Now there's some disadvantages of friction, all right? It makes things very difficult to move, perhaps. A heavy door would be difficult to move. And it also can make moving parts wear out. So like a wrench or things like that, it could strip the wrench. It could make things a little bit too difficult to move, and therefore that's why we use oil and lubricants to kind of loosen things up to make it a little bit smoother. But there are plenty of advantages to friction, far more advantages to friction than there are disadvantages. One of the main advantages of friction is that it enables you to walk. I don't know if you've ever tried sliding on ice, or walking on ice would be more appropriate, but you would tend to try and fall, and it would make it more difficult for anything in the world to actually exist if we didn't have friction. We would not be able to drive. Movement would not exist because if we didn't have friction, if we were driving, we would never be able to stop. Stopping would not happen, and therefore friction allows that to occur. It also allows for things to even just roll in general. Okay, so if you had a wheel on the ground and there was no friction, it would slide on the ground rather than actually rolling on the ground, which is a very important detail with a lot of the mechanics that we have in our everyday life. All right, factors that affect the force of friction would be how smooth something is. Smoothness. If it is a relatively smooth surface, it will have low friction. And if it is not a smooth surface, if it's rough, it would have a lot of friction. A lot of friction. And we determine what the smoothness is and the roughness is by something we call the friction coefficient. Now there are two different friction coefficients, but they kind of represent the same thing. If the object is very rough, it will tend to have static friction, which indicates the object is not moving. Okay, so no movement within the object. So if you push this thing and friction balances it out and it does not move, that would be considered static friction. No movement, that would mean that there is a rough surface most likely, or a very heavy object that you were trying to push it on. And when that occurs, that would indicate that your force of friction was greater than or equal to the force that you applied. Okay, so if you apply less force than the friction that's pushing back against you, you're not going to move. That would be considered static friction. And you will see this as well. You'll see the force of friction is equal to the static friction coefficient times mg, which stands for the force natural. Okay, so the thing that is affecting the force of friction would be your friction coefficient, that's what that ms stands for, and then times the force of natural, and the force of natural would be gravity essentially pushing down on the object, and the force of friction essentially is pushing up with that same amount of force, and so on and so forth. But gravity is the main indicator and one of the main components of friction, as well as that static and or kinetic coefficient. Okay, hey, look at that, ms fn. All right. Kinetic friction would be if the object is moving, then it would have kinetic friction, and your force of friction would be considered smaller than the force applied. So that means that you applied more force, and therefore the object started moving because you applied more force than the force of friction was able to handle. Okay? And when that happens, you will have a slightly different formula. They call it still the force of friction. This part's still the same, mk times mg. I think this is a little confusing because this just deals with your force of friction. It doesn't actually deal with how you would do any problems, okay? I like to think of it as what is actually occurring with your object after friction has occurred. So the object after friction has occurred would be the force of the actual object after friction will be your force applied, and you would have to take away your force of friction. And what did we just learn the force of friction was? Your kinetic coefficient, which is different than your static coefficient, your mk times the force natural, or mass times gravity, or mass times the acceleration of gravity. So this is the formula I tend to use for kinetic friction. I don't like this guy. It doesn't tell me much. I like to use the force of your actual object would be your force applied minus the friction that would be opposing it. Okay? Now there are two different types of friction that you could encounter. And this will be the end before we do examples on the next video. Sliding friction is the normal one that you would deal with, and that would be if the object is on the ground. If you were pushing this way, friction would be opposing it in the other direction. Okay? And it moves against a sliding motion. Rolling friction tends to confuse people. So if you had a wheel, the top of the wheel would be moving to the right. But the bottom of the wheel, assuming the wheel is moving this way. Okay, so if the wheel is movement, if your car is moving to the right, the top of the wheel would be moving the direction of the car, but the bottom of the wheel is actually moving the opposite direction of your car. And because of that, if you think of your wheel, and that part is the part that is actually having contact with the ground, that part is the part that would actually be having friction and dealing with the movement. If your wheel is going this way, your friction would be opposing it, and it would be going the opposite direction of the movement, which kind of confuses some people sometimes, but that is the way it is. Okay, so join me next time where we're going to do some examples with static and kinetic friction, and I will see you then. Until next time, bye.